Hi everyone, I wanted to quickly go into what you guys will be doing this week in lab. So we will have our modules up and you will go down to our lab 2. Okay, and this is what you'll see. It just says to complete the lab. Okay, so what you'll do is you'll download it and open it into a Word document. Okay, and so this is what you'll see. And it goes over your instructions and so forth. But I just wanted to kind of show you that we're not going to be using Pivot this week. We're going to be using FetLab. Okay, so you'll click on that link that I've given. Okay, and it'll show up like this. Okay, so this is what you will see when you open that link. Okay, so I wanted to just kind of give you a brief idea. I'm skipping all of this stuff. You can read it on your own time. Just to kind of give you guys a quick rundown of what you'll be doing. Okay, so for the first portion of the lab, you're going to be looking at forces in 2 dimensions. Okay, so I am going to go with vector addition in 2D. So you click it and you click it again, and it comes up with this. Okay, move this over here. Okay, so this is just an XY plot here, and you can start kind of playing with it to see what these vectors look like when you put them on here and so forth. Okay, you can kind of move them around, you can change the angle, change how large they are. Okay, so I would suggest kind of playing with it to see how everything moves first. Okay. The next thing is it is going to ask you to look at the polar vectors. So I'm going to go on this pink one, and this will give you a description of these vectors in polar coordinates, and that's what we'll be looking at. Okay, so that's what we use a lot of times when we're looking at these trig identities and such. We need some kind of angle involved and magnitude of the vector and so forth. Okay, so this is what you'll be doing or what you'll be looking at. It can be kind of tricky to move this guy around. Okay, so not moving that around, but moving this axis around, this graph. So what you'll do is you'll take your arrow or your pointer and go to this where there's like a little circle. Okay, and you can click on that and move it around. It just makes it easier towards the lab to kind of give it in the middle-ish. Okay, and just to kind of show you guys all of these controls. So again, you can just drag and drop arrows on here. So there's D, here's E, okay? And again, I can change them around. You can notice the angle changes. Okay, this goes from 0 to 90 to 180 and so forth. Okay. You can also change the magnitude. Okay, that's just the length of the vector. Okay, so say I'm just gonna arbitrarily pick a couple of vectors here, okay? And I wanna know my resultant vector, okay? So instead of doing like the tip to tail method on here, I can just say, I wanna know the sum, okay? And so I'll click on that sum right there, and I can place it right there, and it'll give me an idea of the sum of these 2 vectors, okay? And notice if I take my second vector here and I do the tip to tail method, it works out perfectly, okay? So just again, noticing these controls, kind of playing around with it will be helpful. So I've got my sum here. If I click off of that, I can also click values, and it'll tell me my magnitudes of my vectors, but I don't really have to do that because I can just look up here. I've got my magnitude here and my angle. I even have my X and Y components here, okay? I also can look at my angles. Again, I don't really need to do that because I can see them right here. You can click off the grid, doesn't really matter. I'd prefer it on just because you can see everything. Let's see what else. Oh, I want to talk to you really quick about equilibrium, okay? So if I have these two vectors like I just did, okay, and I have my sum vector, okay? Now these two vectors, and in the future, we'll talk about this a little more, but these vectors can represent forces, okay? So if I have two forces, like these two vectors, these pink ones, okay? And I want to know the overall force or the total force of the system, okay? That would be my sum of those two vectors, okay? So again, I have two force vectors, my E and my D, okay? And those two forces will create an overall force, which I'm going to call S, or my sum vector, okay? Now, if I want to know how I can make this into an equilibrium, I can take another force and try to counteract that sum. So see how I'll take it off again. So see how my vector S is in this direction. Okay, it's about 52 degrees. And then when I put this F on it, and notice the length as well is 11, okay, I put this F on here. Let me check my S again. Now it's at 7 magnitude. My magnitude is 7, sorry. And I have an angle of only 8.2. Okay, so it changed it. Okay, so if I play around with this, I can start moving my F and try to counteract my forces, my E and my D forces. Okay, so notice how if this goes away, my S is large. Okay, and if I bring my F or my equilibrium force, okay, into the other direction with some larger magnitude, I'm counteracting those other two forces, okay? Now we can think of this simply also with just getting rid of my E here and saying if I have a force that's like this, and then I have a force that's like that, okay? So this makes sense, hopefully. So if I have a force in this direction, okay, with a magnitude of 10, and then I have a force in the complete opposite direction with the magnitude of 10 as well, okay, these forces will cancel out, okay? So we can call that an equilibrium force. Okay, so again, if you look at my sum now is 0, okay? So let me bring E back. Put it back to where it was about. Okay, somewhere here. So we will be looking at equilibrium forces a little bit in this lab, okay? So watch out for that. And it's not gonna be perfect, so I just tried to make this into equilibrium again, okay? But my sum vector, or my resultant vector here, I wanna get to 0, but I can't quite get it to 0, okay? So it doesn't have to be perfect, but get it as close as you can, okay? So let's see. And then you'll be taking some data, analyzing that data a bit, and then doing it for 3 different vectors. Okay, and then there's some analysis questions at the end, talking about what's a vector, what's a scalar, or some physical quantities that are that, conditions for equilibrium. So think about what I had just talked about. Okay, I guess I'll kind of answer this one right now for you guys. What are the conditions for 2 vectors to be equal? I don't remember if I talked about it before, so let me quickly go over that. Okay, so if I have a vector E that's just like that, okay, and I want to make D equal to that, and it doesn't matter where I place it on here, okay, I want to make D equal to that vector, okay. My vector will need to be in the same direction, first of all. So I need it to be in the same direction, and I'll also need it to be the same magnitude. Okay, so now that it's the same magnitude and direction, these two vectors are equal. Okay. So our E and my D now are both in the same direction and have the same magnitude. So these are equal vectors, okay? Another thing is I want you guys to note for this very last question, it actually took me a little bit of thinking to answer. If you can answer it right off the bat, cool. It's just been a while for me, but what I would suggest for answering number 4, that last question, is to use these arrows and try to answer that question with them. Okay, so it's asking about 2 different forces with different magnitudes, and it's asking the magnitude of the resultant force will be between what 2 numbers, or greater than or less than what values. Okay, so again, I would suggest using these and actually putting it kind of into experiment mode, okay? So I'm not gonna go into that, but I would definitely suggest doing that, okay? All right, so hopefully this lab isn't too difficult. I know there's a lot of words, but it's just to try to explain forces and directions, okay? Which we have gone over, but hopefully this will kind of get you guys into more practice mode of that. All right. Have a good week.